Hi, I'm Dr. Hay. Let's talk about motion diagrams. In a motion diagram, you need three elements. You need position dots, which are like photographs taken of an object at even intervals of time. And you need velocity vectors between each position dot. And you need acceleration vectors, which represent the difference in those velocity vectors. So let's give one a shot. Let's say we've got a car driving at a constant speed and slowing down with a constant acceleration after that. So first we're going to have a car driving at constant speed. Okay, so if something is driving at constant speed, then position dots will be at even increments because the even time intervals. At a later time, the car starts slowing down. It's slowing down with a constant acceleration. Okay, let's add our velocity vectors. The velocity vectors link the position dots. Here's my just positive x-axis. Everything's going in the positive x direction. And finally, I want to add the acceleration vectors. The acceleration vectors are the difference between the final and the initial velocity at any one instant, or one small amount of time. So for example, between here and here, there is no acceleration because there's these two velocity vectors are the same distance, are the same length. And so if I subtract one from the other, if I subtract the first one from the final one, then I'm going to get 0. So there's 0 acceleration here. But when it starts slowing down, the acceleration vectors, for example, if I take this one and minus this vector from it, so let's think about taking this vector and subtracting this one from it. So I'm going to take this distance and turn it around as a vector. The difference here between this location and this one is the acceleration. And you'll notice that if I go from where I started to where I end up, it's going to get me a vector pointing in the opposite direction, which makes sense. You're slowing down. Okay, same thing here. Same thing here. So the length of my acceleration vectors do not change. This is a constant acceleration. Let's get rid of this one. This was just to illustrate our velocity difference. The length of the acceleration vectors don't change. This is a constant acceleration slowing down. The velocity vectors do change. That's because it's slowing down until it stops. Let's consider for a moment a car speeding up. What would the the motion diagram look like for a car speeding up? Okay, so I've got a car stationary. At a little bit later in time, it moves further and further. Can you predict where the velocity and the acceleration vectors are going to point in this case? Here's a velocity vector. It connects the position dots. This time you'll see that because the car is accelerating in the positive x direction, it's going to have acceleration vectors that point in the direction of speeding up. If there's constant acceleration here, the length of these acceleration vectors will not change. It's the velocity that changes. And that's how you draw a motion diagram.